Hello and welcome back. In the series up to this point, we've been reviewing the fluent-data JS library. We've been going in the last video, we've instantiated a matrix, worked with it a little bit, but really didn't go over too deeply into its features. It didn't feel like working with a matrix. In this video, we will resolve that. So we're going to go to the wiki, the matrix page, and pull out the arrays. They're the arrays we had before, but in this case, I think we're going to turn them into arrays right away. Bear with me on this. These all have a similar structure, which is why I'm just cutting and pasting here. So now community turns first into a data set, but right away into a matrix. As mentioned, you can do a matrix right away, but you don't have to. Actually, let's start working with plot A. Oh, this was still an array. All right, so we can get started now. There's plot A right there. What are some things we can expect to do with a matrix? Well, perhaps we can transform or transpose. There we go. We switch rows and columns. Maybe we would want to combine two matrices, add them together. And there's plot A added together with plot B. And if you take a look at plot A's X, for the first row, it's 660. For plot B, it's 112 and some change. And we're in the 700s, so that makes sense. We can also subtract. We're going to get something in the 500s for that first cell. And sure enough, we can multiply. Probably we should transpose plot B, but it is, they're 2 by 2, so this would work, but of course we can transpose within it. One good function to consider, we can transform. Let's do a stretch. We're going to type in the values manually, so we're going to use this nested array syntax. So for a stretch, let's stretch on the x-axis by 10. So to do that, we need a matrix where it's a diagonal matrix. First entry on the diagonal, it will be your x-axis stretch, which is 10. And then your last entry is just a 1. If you don't remember that, don't feel bad. This is not my first take. I've had to look up how to do that. Oh, sorry. Matrix is defined on the fluent-data library. There we go. The y-axis is the same as it was before, originally. Negative 660 and 1320. The x-axis, though, has been multiplied by 10 because we see added zeros at the end. Really important that I show one here, PseudoInverse. It's important not only because it exists, you should know it exists. We'll run that here. But also, it might is one of the items that has a threshold parameter that you can pass to it. So 1e to the negative 8. In the PseudoInverse and in many other algorithms, you calculate it doing an iterative process. And so you got to compare a previous matrix value to a later matrix value. And if the change is by less than a certain amount for any one of the cells, then you stop. Well, what is that amount? I forget what the default is for a pseudo-inverse. I put in 1 e to the -8 here just to show you that you can put it in. Let's force it really small to show what'll happen if you're. It's just going to take too long. It's only going to iterate for so long. There you go. You got an error message. SVD failed to converge. That's because the SVD algorithm is used inside of the pseudo-inverse, and it just took too long. If you want to go deeper into the show objects for what's returned by the throw, you can, and you might learn a little bit more. But suffice it to say, our threshold was too small. What else can we? Let's take a look at the wiki and see what else is available on it. So here's our basic properties. We can, if you needed to know how many rows. So let's do. We've been returning matrices. Let's do some that don't return a matrix. You want the number of rows? It's n row. If you want to know if it's a diagonal, is diagonal. I believe that's a function. So there's 8 rows in the community data set, and it's not diagonal, of course. If you want columns, n column. If you want cells, n cell, and so on. Something else. Certain things don't return scalars, but they also don't return matrices. So let's do one of the decompositions. We're going to go with the defaults, but you can pass in thresholds. Some of them get fairly complicated. And there we go. The data is an array, though. So yeah, there's your A, R, and Q. Let's just look at one of them. Let's do the A. The log twice, or get rid of this. So A is a data set, so it will log and show you its results. And there is the A out of the QR decomposition. Actually, I think that's the original, so we don't really need A. Let's do the Q data set that comes out of it. Very wide, we probably want to shorten that in the log. Round it off so that it'll fit. And there you go. There's our Q and our QR decomposition. We can do our R. Another interesting use, you can create a data set from scratch. Let's say we want to create the identity. So on the matrix object, you can call the identity function that's static. And so let's do an identity length of 5. There you go, diagonal of 1s with 5 rows, where index starts at 0. Obviously, you're going to need that a lot. A lot more available. I'm not going to go over it. You can see some of the properties here. All these return a matrix. Yes, you can solve, validate to make sure it is a matrix, depending on how you instantiated. SVD, that's for compact, which means it's not I believe it means it's not a perfect square. You can eigendecompose. That's really the motivation for me to create the matrix. That was hard. I'll just mention that was hard. Different properties describing the matrix, the norm, whether it can equal another matrix. You can make it just ones. You can make a matrix with random values in it, repeated information. Lots you can do. Of course, there's more we can add to it. I would like to add some of those convenience methods, to be able to shear or shift. So that'll be in the future. But in the meantime, that's what you have available to you. And I hope it's useful. I hope you find it useful.